Okay, I'm going to go over an example of solving a problem using centripetal forces. So really the critical thing when doing this is when solving problems, the most important part is to draw correct free body diagrams or force diagrams. Same thing. And once you've done that, once you've correctly drawn your forces, then you solve a force problem like you've always solved force problem. You add up the forces, see where the net force is, and then use Newton's second law, F equals ma. And like we had in our notes before, there's a couple of examples of different types of circular motion problems. Swinging pendulums, objects going around a curve, so that's like the turntable question. Banked curves, probably won't do that this year, it's kind of complicated. Circular orbits will do that for sure. Here's the, we had a kind of a question like this in the force diagrams. I'm just going to go through it once again. So this ball is going to circle around that center point, and the forces on the ball are Fg and Ft. In order for this to go in circle, there has to be a force pointing towards the center of the circle. In other words, there has to be a force in that direction. There's nothing directly doing it, but this vector there has a component that goes in that direction. So if we look at Ft, it has a component. In this case, I guess we call it, this usually would say that's the angle, theta. So that's theta here. We could call this, I guess, Ft horizontal. So Ft horizontal equals Ft, in this case it's sine theta. Or, since that's the force that's driving it towards the center, that is also the centripetal force. I don't know if, I can't remember if we're going to have practice problems like that, but at least this is an understanding. For sure it's an understanding that you should have, that it's the centripetal forces is the sum of all the forces that point towards the center. It doesn't, and it could be a component or it could be a force all by itself. Okay, let's do an example. Ladybug rounding the corner. So this is just like the piece of plastic on turntable example we saw in class. There's a ladybug going in a circle, and it has a force of friction towards the center, Fn up, Fg down. So first question is, what's the speed of the record at the edge? So how fast is this thing moving? What is v? So v is d over t. Distance is the circumference. So that's equal to 2 pi r. In this case, the whole diameter is actually 15 centimeters. So the radius would be 0.15 divided by 2. So those cancel out. So you get a distance of 0.15 times pi 0.4712 meters. Okay. The time for that one revolution is equal to the period, actually, which is capital T, and that's the inverse of the frequency. So looking at the frequency is 78 RPM, so that's revolutions per minute. So we'll change that to revolutions per second, so that's 1 minute per 60 seconds. So we get 78 divided by 60, 1.3 hertz. Therefore, the period is 1 over 1.3, 0.7692 seconds. So then finally your velocity would be, again, distance divided by time, or circumference divided by period, So 4712 divided by 0.7692, and I get 0.61 meters per second. Okay, what's the centripetal acceleration? Acceleration is v squared over r. So 0.61 squared divided by 0.075. Remember, it's 15 centimeters divided by 2. So I'll square that, and 0.075 divide, I get 5.0 meters per second squared. And as an aside, we could use our other formula, AC equals 4 pi squared r over t squared. It's 4 pi squared 0.075, and then the period we calculated here. Let's try that. So we go, let's get that first. Okay, so I'll use that number in a second. So 4 pi squared multiply 0.075 multiply, and then I'm going to divide by that squared. I get the same answer, 5.0. Okay, let's see. What's the minimum force present? So Fc equals MAC, Newton's second law. F equals MA. So we have 0.001 kilograms times 5.0 meters per second squared. Fc has to be, well, I guess I don't need a calculator for that. It's 5.0 times 10 to the negative 3 newtons. And coefficient of friction. So our formula for friction is mu Fn. And in this case, Fn and Fg are equal because they're balanced vertically. So mu Fg, which is equal to mu mg. So mu equals Ff divided by mg. And in this particular case, Ff is Fc. Fc is pointing towards the center, and that's 100% coming from the friction. So we have 5 times 10 to the negative 3, 0.001 times 9.8. Mu should be 0.001 divide 9.8 divide 0.51.